All right, this is section 3.2, putting it all together, regression and correlation. So make sure that you are reading in your book the suggested reading 185 through 191. So the first thing that the question there on your notes is, does it matter which variable is x and which is y? So the thing is, not for correlation, but yes for regression. Correlation is just going to be the distances between x and y, while the regression, that's just referring to your least squares regression. So your least squares regression line makes the distances of the data points from the line small only in the y direction. If we reverse the roles of the variables, we're going to get a different least squares regression line. So if you think about it, you're switching. So if you think back to what we did on the previous set of notes, how we found slope. It's your correlation times the standard deviation of y divided by standard deviation of x. So if you were reversing those, your slope is definitely going to be different, giving you a least squares regression line. Okay, so so basically this is what I just said. And feel free, pause the video so that you have time to copy this down. Okay, so moving on and looking at these graphs. So take a look at these graphs and take a second and just think, which one do you think is going to have the highest correlation? So if you remember, the more of an oval you can draw around your points, the higher the correlation is going to be. And then the fatter, like the more rounded and the more circle, that's closer to 0 because it looks more like a 0. So even, draw your circles or ovals around those graphs and try to decide which one's going to have the highest correlation. All right, so if we actually draw our lines around these, so just looking at this first one, that's going to be my oval for that one. That's going to be my oval for that one. And so on. Okay, so hopefully your ovals are going to look very, very similar to mine. So even though our graphs look different, they are all the same. So plot your points or plot your data before doing your calculations. Correlation is just a supplement to a scatter plot. It's not the whole story. So even though these graphs look very different, the R value is actually the same for all of them, as well as your least squares regression line. Okay. So make sure you're looking at page 188. That just basically is talking about those 4 graphs that we just did. So take a second, pause the video. Please read through page 188 as far as those graphs go. Okay, so moving on to the next part. How do the outliers affect correlation, least squares regression line, and standard deviation of the residuals, and are outliers influential? So if you think back to before Christmas when we did the applet and we were moving the points around, you put your points close together to try to make a strong correlation. And remember where we put the outliers, because it was one of the questions on the test. And if you want to get, chapter 3 test, your first chapter 3 test back out, you can look at it. But adding an outlier is going to influence your correlation, which is R, as well as your slope and your y-intercept. And we moved it around and we saw how the line would change. So once again, I really want you to pay attention to pages 188 and 189. So really make sure that you are reading those. So points that are outliers in the y direction, meaning, up and down, are going to have larger residuals. So, and if you look at the top of page 189, you've got outliers there for where it's talking about the age at first word. It's got the graph there and the adaptive score. And then child 19 and child 18, those are your outliers. And then if you look in that box there, it gives you your R value and your least squares regression line with all 19 children. And then it takes out child 19 and it takes out child 18. So pay special attention to that and how it's changing. So let's see here. So go ahead and take the time and jot this down for that first question. So, and make sure you are taking the time to read through page 188 and 189. So once again, points that are outliers in the y direction, like child 19, are going to have large residuals because they're further away from the line, whereas child 18 is pretty close to the line. And points that are outliers in the x direction, like child 18, are going to have your smaller residuals. So even though it's an outlier, and once again, make sure you're looking at the graph on page 189, not this one, because this is a different one that's actually showing your notes. So child 18 is further away in the x direction as an outlier, but it's still close to your least squares residual line. So that's not going to affect the residuals quite as much as child 19 would. Okay, so, and one other thing, we call those points influential. So child 18 is actually going to have a bigger impact on the slope in your least squares regression line than child 19. So that's another thing you have to keep in mind. While child 18 is going to have smaller residuals, it's going to impact your least squares regression line more. And so child 18 is going to be considered influential. All right, so looking at this next example on our notes, a scatter plot showing the cost in dollars and the battery life in hours of a sample of netbooks. And the two outliers, so over here, those are the two outliers that it's referring to. So what effect do they have on the least squares regression line, correlation, standard deviation of the residuals, and R squared? So it shows you your least squares regression line with those two outliers. So think about just one easy way to do it. Just draw, we'll do the circle test. Draw your circle around the points without the outliers. So thinking about that circle, think about, your line is going to be something like that. So y-intercept is obviously going to decrease. Slope is going to increase. And we've got more of an oval shape now. So if we switch colors, if we draw a circle around all of our points, it's a little bit more rounded. So R is going to be smaller with the outliers and higher without those outliers. Okay, so I'll go ahead and move this so you can see the full description of what we just talked about. So once again, go ahead and take the time, pause the video, and copy that down. Okay, so our last example, a scatter plot showing the relationship between number of fouls and the number of points scored for NBA players in the 2010-2011 season. So describe the association. Okay, so don't forget to, comment on the type of, you got to do your form, outliers, and your strength, and your shape, like linear or whatever it is. So make sure you're addressing those things. So take just a second, pause the video, and think about those things and how you would describe that. And if we slide it down for part A, so there's a strong positive linear association with no apparent outliers. Okay, so plain and simple for part A. So for part B, should NBA players commit more fouls if they want to score more points? And explain. Well, even though it shows that there's a strong relationship, remember what we talked about. Correlation does not mean causation. Because you score more fouls, that does not mean you're going to score more points. So that is not the cause for that. So there's another variable that influences both fouls and points. So take a second to think about what that could be. How are you going to score more points, and how are you also going to commit more fouls? Well, you're going to have more playing time. So players who are on the court more often, you're going to have more opportunities to score more points. You're also going to have more opportunities to commit fouls than players, who are not on the court as much and not getting as much playing time. So there is our explanation for B. So make sure you just, pause the video and you're able to get that explanation down. And that concludes notes for this section.